Turn the page there. So we've got question J and K, and then question 2 on page 50 of our notes books. So same deal, we're trying to find the derivative function, but if we're looking at this, we're going, I've got something at the top, something at the bottom. I need to simplify it first. Remember, we need everything at the top of the fraction expressed as a single power of n. So what we're going to do here is what we call splitting the denominator. And so there's a fair few operations we need to perform before we can differentiate it. We're going to first express it like this. Okay, we're splitting the terms about the denominator. Notice, guys, notice how if you were to add them together, they would collect over that same denominator. Now we're going to simplify them using index laws, all right? At the top here, the power is 1. So if I'm just focusing on this term, they have the same base, so I can do the top power, take away the bottom power. All right, it becomes x to the power of the top power, take the bottom power. This term, we're going to just move the x to the top and make the power negative. One take away 2, that's going to be minus 1. Okay. So what have we done? We split the denominator and we've simplified each term using index laws. Look, here's the function, here's another way to express it, here's another way to express it, here it is fully simplified. Everything at the top of the fraction, x to the power of n, we're ready to differentiate in one step. So we're moving from f of x, here's f dash of x. Applying the power rule, this becomes minus x to the minus 2, and this becomes the 5, just hangs out, minus 2x to the minus 3. Okay, I've said you get full marks there. The textbook will simplify it. You need to understand how to simplify it. So that would be minus 1 on x squared. This one would be minus 10 on x to the power of 3. Okay, there's the minus. 5 times 2 is 10. X to the minus 3 becomes x to the 3 to the bottom. All right, on to the next one. So these are popping up in the later parts of question 2 and question 3. Now, this is going to be a nasty one. Now, it does express it as the cube root of x. I've put it as x to the power of a third. They mean the same thing, all right? Let me use the same notation you've got, and in the next step, I'll simplify it. Okay, so step 1 for us is to split that denominator, all right? Whenever we have a fraction, we're going to need to simplify it. We're going to split the denominator. So we have 2x to the 4 on x to the power of a third. Okay, so in the first step, I'm changing it from the cube root of x to x to the third, and I'm splitting the denominator. Now, x over here by itself, you don't need to put the 1 there, but I'm putting it there to show you they have the same base, so we can modify the powers. All right, now let's simplify using index laws. It's the top power take away the bottom power. So we have 4 take a third on the first term. And then we have 1 take a third on the second term. Okay, 4 take a third, that's something you can do in your calculator, but it's the same as 12 on 3, take 1 on 3. It's 11 on 3, and this will be 2 on 3. That's what it simplifies to. Okay, so we did the same thing, right? We split the denominator, and we've simplified using index laws. We've expressed everything as x to the power of n at the top of the fraction. Ready to differentiate. Here we go. F dash of x is n. So the 2's hanging out. N x power of n take 1. Alright, well, let's do it as a big mess first, and then we'll simplify it. And then the same over here, nx to the n take 1. Alright, so we've simplified to there, the 2's hanging out, nx n take 1, nx n take 1. Okay, and then just to simplify, 2 times 11 on 3, 2 times 11 is 22. And then we have at the top here, 11 on 3 take 1 will be 8 on 3. And over here we've got 2/3 of x to the power of 2/3 take 1 will be minus 1/3. Alright, so that was a pretty messy one, right? Messy because of the fraction involved. Hopefully the process makes sense though. Split the denominator, simplify index laws, and then just apply the power rule. Okay, last one. Find the slope of y equals 3 on the square root of x when x is 1. Okay, remember, if you have y equals f of x, that's the function. dy on dx is f dash of x. That's the slope function. We need to find the slope function, and then we're going to put x is 1 into the slope function. We want to know the slope when x is 1. So in order to differentiate this, first we need to express it at the top of the fraction as a power of n. So this becomes 3 times x to the half. Okay, still the same function. Now let's differentiate it in one step. N, x, n take 1. Okay, the 3 is just hanging out the front. Okay, then we can expand and simplify this. So it becomes 3 on 2, and x to the minus half is 1 on root x. So the derivative function is 3 on 2 root x. We want to know the slope when x is 1. And so when x is 1, dy on dx will be 3 on top of 2 root 1, 3 on 2. Okay, so there's 2 parts where it gets a little bit trickier. Is it? Yep, find the slope function. Okay, now put an x value into it. Well, that's what it means when it wants you to find the slope. Using the derivative, put the x value into the derivative function. Alright, so that's enough to finish this exercise. Now,